On page 11.9 of our notes, we are going to look at dividing radicals. So you will see that we have a big radical sign with a fraction underneath for some of these, and then other ones, they are broken apart into two separate radicals. The neat thing about that is it can go back and forth. So that's what part 1 says, break apart the radicands using the quotient rule. So if you have a big square root with a fraction underneath, you can separate it into two separate radicals. But it can also go backwards. So some of them we're actually going to divide before we do the square roots. Other ones we want to break them apart right away. Step 2 says to look for perfect squares and simplify those. So that's always your hope, is that there's a perfect square. If not, then we're going to simplify our fractions. Then we might need to simplify our square roots as well. So if we look at number 1, we're going to do all the odd ones first and then go back and do the even ones. So for number 1, if we look at 49 and 100, those are both perfect squares. So some of you might not need to take this step to actually write them like this, but it is helpful to see that that is what we're actually doing, is we're simplifying it by taking the square root of each one separately. So then the square root of 49 is 7, the square root of 100 is 10, and we are finished. So some of your answers might come out to actual fractions with numbers in them instead of square roots. When we look at number 3, 3 is not a perfect square, but 16 is. So it's very important to either have your square roots memorized or have that perfect square list and look on that. So what we're going to do is we're going to again break this into the square root of 3 over the square root of 16. We cannot do anything to the square root of 3. There's no perfect squares in it, so it stays. The square root of 16 is 4, and we are finished. To be considered simplified, you cannot have square roots in the bottom. So all of these problems, you should end up without a square root in the bottom, in the denominator. When we look at number 5, 10 and 45, neither one of those are perfect squares. So I'm actually going to write a bunch of steps out, and you will be able to skip a lot of these steps. So what you want to think of is, since those can't be broken down with perfect squares, we are actually going to make this 10 over 45 inside the square root sign. So instead of having two separate square roots, we're going to make them into one big square root. So then you can simplify 10 over 45. 5 goes into both of them, or you can use your fraction key. We would get 2 over 9. And now we have a perfect square. So then we can do square root of 2 over square root of 9. So you could hopefully go from this step right down to this one. Just imagine that you are taking the square root sign to the outside, separate or simplify 10 over 45, and you get 2 over 9, then just put the square root signs back in. So you do not have to write all of this out unless that's helpful to you. You can actually just simplify 10 over 45 and write it with both square roots. So square root of 2 can't get broken down. The square root of 9 is 3. So square root of 2 over 3 is your final answer. Number 7 is the same thing. 96 and 3 are not perfect squares. So you can take 96 divided by 3. If you need to look at it like this, you can do that. 96 divided by 3 is actually an integer. It's 32. So we have the square root of 32. So then we need to look to see if there are any perfect squares that go into 32, and there are. 16 times 2 gives us 32. So square root, our final answer is 4 square root of 2. For number 9, the 3 is just going to come along. So I'm going to write all the steps out again like I did up in number 5. We're going to have the 3, and then we need to simplify 5 over 45. 5 over 45 simplifies to 1/9. So we have 3 square root of 1 over 9. So we have 3 square root of 1 on the top, square root of 9 on the bottom. So you can put that 3 back up on the top. Square root of 1 is just 1, so 3 times 1 is 3. Over the square root of 9 is 3, so this actually simplifies to just 1. Number 11, you can actually divide 10 divided by 2. So if there's numbers out in front, both top and bottom, you do want to divide or you have to simplify if they don't divide evenly. This one does, so we have 5, and then we need to do the square root of 48 over 3. Again, if you don't need to write that step out, great. Just do 48 divided by 3 in your calculator, and you will notice you get 16. So 5 square root of 16. 6 square root of 16 becomes 4. 5 times 4 is 20 for our final answer. So now that you've watched those, you might want to pause it and try each of the even ones and see if you can get those correct. So if we go back and look at number 2, 8 and 32 are not perfect squares, so we're going to simplify 8 over 32. 8 over 32 simplifies to 1/4. So we really are looking at the square root of 1/4, which means we can do square root of 1 over square root of 4. Those are both perfect squares. So our final answer is 1/2. Again, if you are able to just right away simplify square root of 8 over 32 to 1/4, you can go ahead and do that. I don't know why I wrote that in there. Number 4 is a little tricky. Some people want to simplify 7 over 49, but we actually don't know how to do that problem yet. You want to just see this as square root of 7 over square root of 49. Anytime there's a perfect square, you want to get rid of that right away. So square root of 7 stays, square root of 49 is positive 7. Those do not cancel out because 7 in the top is under the square root. So that's your final answer. So same thing with number 6. It's tempting to simplify 12 over 36, but we don't want to do that. We know that the square root of 36 is 6. 12 can be broken down. So 12 gets broken into 4 times 3. So you can break that down right away. So we would end up with 2 square root of 3 over 6. However, that is not my final answer because your outside numbers can be simplified. So 2 over 6 simplifies to 1 over 3. So our final answer is just square root of 3 over 3. Number 8, we're going to change this to 7 times the square root of 108 over 6. So 7 times the square root of 18. Again, if you can skip that step and just do 108 divided by 6 in your calculator and then remember to put it back under the square root, that's fine. 18 gets broken into 9 and 2, so we have square root, square root. Some people like to write that all in a line like this. If that's helpful, you can totally do that. Square root of 9 becomes 3, that's multiplication. So 21 square root of 2 is our final answer. For number 10, 4 and 3 cannot be simplified, so I'm just going to bring those right along. We need to simplify 15 and 27. So in your calculators, you can just simplify 15 over 27, or we divide those both by 3 and we get 5 and 9. So just keep those under the square root signs. So instead of taking that step where I wrote it as square root of 15 over 27, I just went ahead and did that to simplify it and left them separated. So we cannot simplify the top at all. So 4 square root of 5 goes along the top. Square root of 9 is 3. 3 times 3 is 9. 4 over 9 cannot be simplified, so that's your final answer. 4 square root of 5 over 9. Number 12, we can simplify 3 over 15 to 1 over 5. And then we can do 84 divided by 7 and get 12. So we have square root of 12 on the top. We don't need that 1 then. Square root of 12 gets broken into 4 times 3, both under the square root. And don't forget the 5 on the bottom. Square root of 4 becomes 2. So our final answer is 2 square root of 3 all over 5. So again, first thing you can do is you can split apart a square root with a fraction into 2 separate square roots. Or you can take one that is separated and turn it back into one big one. So we always want to see if there's a perfect square. If there is, we do that. If not, we actually simplify our fraction and then simplify our square roots.